Okay, so for your learning log entry, you've got this is actually attached. So go ahead and take those apart. You need to then go ahead and put this in your next available page. Probably should be, I don't know, I think maybe page 8 or so. Um, okay, so here are the learning targets and the entries that you're going to need to put in for chapter 2. So we've got a couple learning log entries, a few math notes, but we're just going to get kind of this first few things done. Okay. The learning targets for this chapter. So by the end of the chapter, you should be able to graph a linear function given the slope and the y-intercept, write an equation from a graph table in a situation, interpret the slope and y-intercept from a graph table equation and situation, determine the slope given 2 points, where one of them is not necessarily just the y-intercept. Um, Understand that slope is a unit rate. Write an equation of a line from a graph or table that does not contain the y-intercept. Algebraically, so that's kind of important, algebraically determine the equation of a line given the slope and a point. So basically, you have to solve for the y-intercept, and then algebraically determine the equation of a line given 2 points. Okay, so by the end of this chapter, here are some of the major vocab words you're going to need to know by the end. So look through these different things. If there's something that you don't know by the end of the chapter, you'll definitely want to review these. Okay, so at this point, early on in chapter 2, we should know what a graph is, a linear equation, starting value, figure 0. Function is really from last one. We should know y equals mx plus b is the general form of a linear. We've been working with variables, y-intercepts. We'll be seeing what zero slope is. Next week, we'll look at a piecewise function. Rate of change is something, a way of defining slope. We've been looking at some different situations that will involve linear relationships. Change in x or delta x, we've used that to help us figure out the slope. We'll get to a parameter. We've made some slope triangles already. Unit rate is another way of looking at what the slope is. The growth is another way in a situation to be determining what the slope is. Delta y or change in y, we've used that in our slope triangles to help us determine the slope. Steepness of a graph, ultimately another name kind of for slope. X-intercept coefficient, we've been using that as the number multiplied by a variable, and we've been looking at some tables. Okay, so we're going to now put a learning log entry in. So go ahead and turn your page and write down multiple representation depth focusing, huh? Multiple representation web for linear functions. All right, so the very beginning of this unit, we said that there are sort of 4 different modalities that you need to be aware of. You should be able to look at the linear function in table form, in equation form, in graph form, okay, and in situation form. All right, so where are you now? If you're given a linear equation, do you think you can generate a table from that? We did a little bit of that when we looked at a pattern y equals 3x plus 1. Okay, so we remember the zero figure had one tile and then it was growing by 3. You had to generate a table from that? Do you feel confident you could do that? Okay. We also looked at taking some equations and trying to graph them. So is that something you can do? Okay. So if you're given an equation, you know that this is the y-intercept, The 1 and the 3 is the slope. It's going to go over 1 up 3 to make the next point. Okay. If you're given a graph, can you then figure out what points you would put into a table? Okay. Given a table, could you then graph those points? Um, Given a graph, could you come up with the equations? We did a little bit of practice. Did a little bit of practice on that in the last lesson, where you had to find the slope and the y-intercept and put it in equation form. Okay, so given a table of values, could you come up with the equation that goes with it? Could you find the y-intercept from the table and then generate the slope by thinking about the change in y versus the change in x? Okay. How about if you were given a story, could you put it in equation form? Could you figure out what the slope is? Okay, and then work from that the rate of change. So, like in the tile problems, could you figure out the zero? How many tiles were in figure 0, and then how it's growing? Okay. If you had that story, could you also make a graph of it? Okay. If you were given a linear graph, could you figure out a story that would maybe go with that? Okay. If you had an equation, something like this, could you figure out what maybe the tile pattern would be like? Okay. So same with situation. If you're given a tile pattern, could you make a table of values for that? All right. If you had a table of values, could you come up with maybe a tile pattern that might match that? Okay. So some of these links might be a little weak at this point, but we'll be working on strengthening those so that if for a linear function you have any one of those things, you should be able to find the other three. Okay, next learning log entry was to focus on the equation y equals mx plus b, which is the general form of a linear equation. So let's think about what those forms mean. Okay, so in y equals mx plus b, okay, x is considered our independent variable. Okay, or basically like our input. Okay, y then is our dependent variable. Okay, m in this is our rate of change. Okay, also known as our slope. Okay, maybe I probably should say unit rate of change. Okay, so it's the amount that our dependent variable changes by every time our independent variable changes by 1. Okay, what's our b value in this formula? Okay, in a linear relationship, the b is graphically is the y-intercept. Okay, story wise, it's some kind of like starting value. Okay, so it was like the amount of tiles in figure 0. Okay, so let's look specifically at each of these, the kind of 4 things from above, and see how do you figure out what the M and the B are. So if I had a situation like a tile pattern, some kind of story, okay, what would the M be? How would I find that in a story? Well, if it's a linear relationship, the M would be whatever the unit rate of change is. Okay, so like in our tile problems, it would be the amount of change from each figure number, how many additional tiles, okay, were added on. Okay, in some kind of story, our B value would be our, um, the amount we started with. So, okay, so the amount we have when our independent variable is 0. So in the tile problems, the B value was the number of tiles in figure 0. All right, how about in a table? How do you find the M? So when you have a table of values, you're going to find the unit rate of change by looking at the change in the y value when x increases by 1. Okay, where do you find the b value in a table? Okay, that's going to be the y value when x is 0. Okay, so how do we find those two important things in our equation? All right, so the m, okay, the rate of change is always the coefficient of x, okay, the multiplier of x, and our b value is the constant term. Okay, so the value that's not tied with the x, okay, that will give us our starting value. All right, how about graphically? How do we figure out what the m is, or the rate of change, the unit rate? We find the slope. Okay, and you do that by finding the change in y and dividing that by the change in x. All right, and looking at a graph, where do we find the b value? All right, so that's the y-intercept, so that's just where the line crosses the y-axis. Okay, will be our y-intercept. Okay, so putting together then on the next page, go ahead and glue in this math note. Okay, and it talks about in detail how to find the slope of a line. That basically it's the ratio of the vertical change, the delta x, to the horizontal, change in y, the delta y relative to delta x. So how much the y value changes for any amount of x change, you can just divide those to find the unit rate. Okay. It also talks about that lines pointing upwards. Okay, these kind of lines should have positive slopes. Lines pointing downwards should have negative slopes. A horizontal line, so a line going straight across, should have a slope of 0. Okay, and a vertical line would be considered having no slope, because if we took the change in y and tried to divide it by a change in x, the change in x would be 0. So it would be considered undefined. So either undefined or 0 slope, or you could also say no slope if you have a horizontal line. You can always calculate the slope of a line by picking 2 points on the line, drawing a slope triangle, finding the change in y or change in x, and coming up with that ratio. Okay, you could also just use this little formula to find the slope between the 2 points. You could find the change in the y value, so just subtract those two and divide it by the change in the x values. Okay, so taking it back to the tile problems, the change in x would be how many figure numbers later. The change in y would be how many additional tiles. So if you wanted to find the unit rate, how much it just changes for one additional figure number, you could divide those two values. Okay, so that's the end of the notes that you need to fill in for now.